what we got here is the intersection of shorted array. The finding the intersection of two shorted array. What it means, you need to find whenever those two arrays have the same values. But the main point to note in here is those facts. They are sorted and they are both sorted. So if I want to know which one happened, I've got two things I need to think about. The first one is to think what is the meaning? Can be some of them missing. So it's kind of misleading the way they wrote it, but in purpose, they want you to miss the fact that not all items from B must happen inside A. So you need to ask that. And another point to note is that how to solve it. So since it's sorted, what I'm going to do is going to put a pointer in here and a pointer in there and progress them. But they are sorted, so I don't need to do a stupid progress. I need to do something a little bit smarter to use the word sorted. What I'm going to do is to start by asking, is A bigger or smaller than B? As long it's smaller, I need to progress it. It need to move to here, to is still too small. Okay, this one is the first one that is not smaller. Then I'm going to ask, does it equal? If it's equal, great, I got a match. I'm going to add it to the result and move it one ahead. So I'm moving it one ahead and in here, okay, great match. Okay, it's moving it the B pointer. So now the 5 is still too small, so I can move it again. The 4, and I move to 5, finish the list of B, I can go out. Okay, so this is part 1. So part 2 will be to go down and write the code. So the code in here is go like this. Here is the code. You can go like that. You check in what is the size, and then I'm going to return all the corner cases. Then I'm going to scan. As long B is bigger than A must progress as fast as it can. The first time it's not the same, it means that B maybe needs to improve, but before I move B ahead, I need to compare them. So if I compare and B equal A, then A must move as well 1. So, add into result, easy peasy.